In the previous Kubernetes security-related videos, we discussed an overview of Kubernetes authentication model. Let's go ahead and discuss that process to be a refresher. Any communication between a user or a worker node, for that matter, to the API server needs to be authenticated. So the request goes to the authentication module, and then if you recall, we mentioned that authentication and authorization process are pluggable. That is, a number of different options are available to administrators to enable authentication and authorization. For authentication, we have X509 certificate, client certificates, which is the default. We can also use OpenID Connect or static token files or webhooks. Let's go through each one of those. So these are the authentication, different methods of authentication. So as mentioned, X509 client certificates, that is the default method of authenticating both the users and also the worker nodes to the API server. And an administrator can enable X509 certificate by passing this flag, which is -- client -ca.file is equal to the location of the file. And the file will, reference file must contain one or more certificate authorities to use to validate client certificate presented to the API server. So also note that Kubernetes has its own PKI certificate, PKI infrastructure, and provides certificates as needed. Although you can also use, if you have an organizational CA already set up, you can enable that to Kubernetes, and Kubernetes can use it. But by default, out of the box, it has its own PKI and issues its own certificate. So in this episode, we will dig deeper into this method and how that works and how the PKI infrastructure is set up in Kubernetes. Another option is OpenID Connect tokens. So OpenID Connect is a flavor of OAuth 2, supported by some OAuth 2 providers such as Azure Active Directory, Salesforce, Google. So these are cloud-based infrastructure, but you can also use some other ones such as Okta that we will be covering in a future episode. So you don't have to rely on Azure or Google, for that matter, or AWS. You can also set up your own infrastructure, and we go through that in a future episode. So the difference between OpenID Connect and OAuth 2 is it really depends on OpenConnect, depends on OAuth 2, but it has an additional field returned with the access token called ID token. This ID token is really a JSON web token, and that has the claims, that is the information, the attributes about the user, such as usernames, organizational unit, and email, and so on. Another option is to use static open file. And for this, administrator will need to actually generate the tokens for various users and then save them into a file. And then it passes the location of that file into Kubernetes. And when Kubernetes starts, then it will use those for authentication. So obviously, this is not a good way in the production environment. This is good for learning purposes, or if you want to set up an environment quickly and use that, so it might be an option. And finally, webhook is another method of authentication like OpenConnect. This basically, Kubernetes relies on external providers such as LDAP or Samuel or Kerberos, or alternative X509 schemas that can be hooked then into Kubernetes, and Kubernetes can use them through webhook. And these are various flags that needs to be sent to set in the API server. So once the user is authenticated, then needs to be authorized. And again, authorization is pluggable, and we discussed those in detail in the previous episode, in the first episode of the security-related videos. Those options include role-based access control, and we spend the whole video on that. Or you can use attribute-based access control, RBAC, ABAC, or webhook. Again, webhook is another option for authentication as authorization as it was for authorization. And node authorization is a specific module that is used to authorize the kubelet. There are two types of users in Kubernetes: regular users or people, and service accounts. Service accounts are created and maintained by Kubernetes. Regular users, on the other hand, are managed by systems outside Kubernetes. So as we mentioned in the previous screen, the users could be either in saving client certificates if you're using X509 certificate authentication, or OpenID Connect infrastructure, and so user will be in those directories, or could be in LDAPs or some other external providers. There is no object to represent a regular user, nor any API to create and delete users. So keep that in mind that, again, Kubernetes really does not maintain people. Supported authentication credentials types are, again, client certificates or bearer tokens, depending on what kind of authentication module will be used, or authenticating proxy or webhook. So again, this will allow integration with other authentication protocols such as LTAP, SAML, etc. So these are the types of supported authentication credential type in Kubernetes. Service accounts are used for authentication and authorization against the API server, and also could be used as a pod identity for enforcing network policies that we will discuss in the future. A service account is an automatically enabled authenticator that uses signed bearer tokens to verify requests. The plugin takes two optional flags. The first one is -- service account -key file, a file containing a PEM encoded key for signing bearer tokens. If unspecified, the API server's ATLS private key will be used. Also, another flag that can be used, -- service account -lookup, if enabled, tokens which are deleted from the API will be revoked. By default, the default service accounts are created automatically by the API server and associated with pods running in the cluster through the service account admission controller. So basically what it means is when we create a new namespace, it automatically creates a service account called default. And all the pods that are created within that namespace, that are automatically associated with that namespace. Specific service accounts can be created and associated with pods using the service account field of a pod spec. And we'll take a look at it in the demo. Service accounts are stored as secrets and consist of a CA certificate, a token, and a namespace. Bearer tokens are mounted into a pod as file using volume located at, this is the location of where it actually mounts, and allow pods to talk to the API server. So basically, the certificates and the token that is used here, that are saved here, that's how a pod can authenticate. If it needs to talk to the API server, that's how it uses that certificate and token to talk to API server. We can create service account in two ways, through YAML. So this is the important section, API version v1, kind service account, And metadata, we specify a name for it, and for instance, my service account. You can do it also from command line. Create service account, my service account. To assign it to a pod specified in the pod spec. Yeah, so over here. So when you create when you generate or when you create a YAML to create a pod, and in the spec section of the pod, you can say service account name, and you can assign it to it, and then you can then specify the containers and everything else. So in the upcoming demo, we'll investigate the clusters, authentication, and authorization settings. Basically, we'll investigate for the cluster that I've set up, and you can do it on your own cluster also. See what authentication and authorization modules have been, by default, have been enabled. We'll also take a look at service accounts, how to delete, to create them, and how to assign them to a pod, and also we'll take a look at where the certificate resides. So we are in Visual Studio Code now to investigate what authentication and authorization modules have been enabled, the first thing that we'll do. And so the authorization is under -- authorization mode equal to, and the whatever modules that have been enabled for authorization, we should see that in the API server YAML file. And then for authentication, these are the ones. The first one is CA -- client CA.file equal to. If that's set, which means that client certificate authentication is enabled. And then below that, -- enable bootstrap -- token -- auth equal to. If that's set to yes, which means that bootstrap authentication is also enabled. And below that, anything that starts with -- OIDC, that an indication that OpenID2 authentication has been enabled. And then below that, -- token auth file equal to, and that signifies that static token authentication has been enabled. So let's go ahead and open the API server YAML file, which is saved over here under this location. Let's open that. And we scroll down. We'll see that -- authorization node is set to, or authorization mode is set to node and RBAC. And don't worry about those. We'll talk about those in details a little bit later. But just know that these two authorization module has been enabled. And immediately below that, we'll see that -- client CA.file equal to, and this is the CA cert, the location of CA cert. So now we know that the client certificate authentication is also enabled. And let's look for enable bootstrap, and we'll see that over here. So enable the bootstrap token authentication is also enabled. Then we'll look for -- OIDC. We'll see that if OpenID2 has been enabled, which we'll see that is missing here, which is, I haven't enabled that. And then the last one is -- token auth file. Let's go ahead and look for -- token. We'll see that there's nothing here. So the first two of this authentication, that is the CA cert authentication and bootstrap token, have been enabled by default. So when I installed Kubernetes, this is what it set that for me. Now on line 22, let's go ahead and create a service account. So let's go ahead and here, as I showed you earlier in the presentation part, I will specify the API version, and the kind is service account, and the metadata, then we select a name. So this is the name that I chosen. So let's go ahead and now apply that. So line 12, kubectl apply -f and the name of the YAML file, and the service account was created. On line 15, kubectl get service account, and the name of my service account -o YAML. Basically show me that service account that I just created and represented it as a YAML Let's go ahead and run that. And we'll see that at the bottom, there's a secret section and then there's secret name. So recall that service accounts are associated with secrets. So this is a secret that is associated with this service account, or they're represented by service account. And then on line 16, I'm going to capture that name, the name of that service account, and I'm going to put it into variable, and I'm going to echo it out to make sure I got the right one. Yeah, this is the correct secret. And then on line 19, kubectl describe secret, my secret, let's go ahead for the service account. And we'll see that inside the secret, there's a ca.cert. So actually it's got there's a certificate embedded, and that is the CA certificate issued by Kubernetes. Basically, this is used when this service account, it has to talk to API server. This API server will, because this is TLS, it will present its certificate, the API server. And this will then verify, compare the CA cert that has within itself to make sure that it's talking to the right cluster. And then this is the token. So this is actually the token that it will be using for authenticating against API server if it needs to talk to the API server. On line 24, let's go ahead now and create a deployment. And inside that, we're going to associate the service account we just created. We're going to associate it with this deployment. So again, the kind is deployment, and then I'm sure you know the rest, how to create a deployment. And the important part is here under spec. So this is the spec for the pod, and the service account. We can set it to whatever service account we want. And then I'm setting it to the service account we just created. So recall, if we don't set this service account over here, it will set it to the default service account. That is the service account that was created when the namespace was created. So let's go ahead now and apply that. Line 24, kubectl apply -f, and then of YAML file. We'll see that it was created. Now I'm going to capture, first of all, let's go ahead and take a look at the pods that we have here. Kubectl get pods. And we see we have only one pod here. I'm going to capture that pod and put it into a variable on line 27. On line 28, I'm going to echo it out to make sure I got the right one. Yeah, this is the correct name. And now on line 31, I'm going to show to get the pod, I'm going to represent it as YAML. And what I'm going to do is I'm going to look for where the secret will be mounted inside the pod. So let's go ahead and do that. If you go scroll up a little over here, the volumes, you see the path dash mount path, and so this is the location where the secret will be mounted on under /var/run/secrets/kubernetes.io and service account. Let's go ahead and exit that and clear that as well. And now on line 34, we're going to actually exec inside and get inside that pod. So kubectl exec -it and the pod name and sh. Let's go ahead and now we are inside pod. And then I'm going to do a listing of the location that we just saw inside our pod, so which is -var/run/secrets and the rest of it. Let's go ahead and run that. We'll see that it's got ca.cert, so that's the client or the CA certificate. The namespace, so this file will has the namespace that this service account belongs to, and the token. So the value of the token will be inside another file. So basically this is the file, or this is the location that this pod will be using if it needs to talk to API server. Kubernetes uses certificates both for TLS encryption and also for authentication, both client, again, that's the default behavior, and also for various components within the control plane when they want to talk to the API server, or if the API server wants to talk to other components. So when admins, Kubernetes admins set up Kubernetes and initiate the cluster, as part of the setup, it will also set up a PKI infrastructure, and that is how certificates are generated and distributed to various components. So this is kind of the default behavior. If you have your own PKI and you want to use that, and you don't want to use self-signed certificate issued by Kubernetes, then you can do that. I'll provide the link in the readme.doc, so you can follow that and set it up if you want to go that way. But by default, it uses its own PKI and self-signed certificates. Okay, as part of that, then various certificates are generated, and they're usually under etc Kubernetes, that's the root, and then below that, there are various other folders that contain certificates. For instance, the PKI folder, and these are the certificates that will reside under that. And there's another one which is not shown here, is the etcd folder, and that's where etcd certificates are under that. But for now, I'm just going to go over some of the more important ones shown here. The first one is admin.conf. So this is the configuration which contains the client certificate, the key, client key for that certificate, the CA certificate, and information about how to connect to the server, to Kubernetes cluster. And that is generated when you set up Kubernetes. And that is the file that you, generally you copy that as once the cluster is initialized, you copy that to your own folder in your home directory .cube. You copy that as part of the installation process. So this is really, we can consider that as the key to the kingdom, your Kubernetes kingdom. So if this is compromised, then you have to assume that your entire Kubernetes cluster is consumed. So be very careful of this and protect this. And do not distribute that to anyone outside your Kubernetes admins. We will go through the process of generating certificates for other team members, the non-Kubernetes team admins, but this is only meant for the Kubernetes admin and should only be circulated to Kubernetes admins. So this is one of those best practices. Be extremely careful with this, because anybody who has a certificate will be able to connect to API server, and they can do whatever they want. There is no limit to what they can do. Anyway, moving on, the controller-manager.conf. Basically, this is a certificate that this control manager uses to talk to API server. And scheduler.conf is the certificate that scheduler uses to talk to the API server. And then below that, under the PKI subdirectory, we have API server etcd-client.cert, which is this one, and its private key. And so this certificate is used by the API server to talk to etcd. And API server-kubelet-client.cert, this is a certificate and its private key that API server uses to talk to the kubelet on the nodes, various nodes. And then API server.cert, this is its own identity or certificate, and this is its private key. And CA cert, so this is the generated PKI self-signed certificate, and this is basically trusted in the cluster. So every time that you generate a configuration file, and CA cert also is included in that, and that is how a client can trust that this is the right Kubernetes cluster they're talking to. So basically, that's kind of establishes the trust between them. One of the functions that it does. Once the cluster, the control plane is set up, then admins will then set up various nodes, and then within each node, under etc Kubernetes, there's the kubelet.config file. Again, this is for Kubernetes or kubelet to talk to API server. So kubelet, this is how it uses the certificate to talk to the API server. It also has below that and the PKI. Again, this is a certificate that's issued by this self-signed PKI infrastructure. And for clients such as developers, then admins will need to request or generate certificate, and we'll go through that process in the following up screen. We'll go through the process of how we can do that, and then once they get generated a certificate for the client, then they create a config file. We go through the process of how they can create a config file for the client, and then they send it to the developer. Developer then create a .q folder under in their home directory, and then copy the config file into that folder. And that is how they are authenticated against API server. So in this section, we are going through the process of generating a brand new certificate, client certificate for one of our developers, whose name is John Doe. He has just joined our team, and the Kubernetes admin will need to generate a client certificate for him, and then later on generate a config file for him so he can communicate with Kubernetes. So I'll go through the process of overall process of how we do that, and don't worry so much about the syntax of doing that. We'll go through that again in the demo, and also you'll have the scripts to go through that yourself, but just understand the high-level steps required as an admin, how you need to generate the certificate. So the first thing that you need to do is generate a private key, and you can use OpenSSL, gen RSA, and then out john.o.key. So that would be the generated file that will contain the private key, and this is the strength of the private key, which is 2048-bit. So once we run that, we'll generate john.o.key, so that would contain the private key for John. Next, we need to generate a certificate signing request, or CSR, and this is the command: OpenSSL req -new -key, and then the name of the file. So basically, we are going to, as input, we'll specify the private key. So this file will have the private key. We specify it here as a new key section here, and then -out. The output will be copied to this file, john.do.csr, and then we need to specify -subject. So basically, the name of on the certificate, and that's signified by /cn, equal to the name of our user is john.do. And then /o, this is for organizational unit. And I highly recommend that you assign roles or assign your developers to roles. In this case, for instance, we have 2 roles for John, so marketing and then HR. So this is how you specify O equal to marketing -dev/O equal to again. So you can specify as many roles as John will be, that he'll be in over here. And that makes managing users a lot easier than giving access to object in Kubernetes by name of the user. Because you can, assign the whole group of people, let's say assign them or give them access to, let's say, be able to deploy pods. So rather than each assign that permission, we'll go through that later on during the demos, but rather than giving each individual person access to, let's say, that right, that function, we can then assign a group of people instantly to have that right. So it makes again, it's optional, but I would highly recommend doing that. And it really doesn't matter if you're using client certificate or if you're using OpenID2 infrastructure, do the same thing. That even makes your life easier if you have a centralized place where you can manage your groups. It actually makes it easier for you. Anyway, so once that's done, then it will create this file called john.do.csr. We need to do one more step. We need to actually now encode the content of this file. So we need to, and then generate a new file. So we open that file, we just generated here the content, we pump it through base64 encoding, we remove some header and trailer information, and then we pump it into another file called john.do, new file called john.do.base64.csr. So let's do that. And now this is actually the CSR that we can send to the API server and get to generate a certificate. So next step is to actually submit that CSR to the API server. And we can do that on the fly through what is known as here doc. So we say cat less than EOF. So basically we're saying that we're generating a file on the fly, and then everything starting from here till we hit the EOF, here they're all part of one file. So basically we're generating a YAML on the fly. Then we need to specify the instructions, so kubectl apply -f, and then this is the content or the generated on the fly generated YAML that kubectl will apply to. We'll need to specify the API version, which is certificate.k8s.io/v1. The kind will be certificate signing request. And the metadata, we need to specify a name for this request. So don't confuse this name with the name on the certificate. It's basically a name for our request. And then under group, we need to specify system authenticated. So this is a built-in group that we need to add the users to. And the request, this basically we open the CSR that we generated earlier. So we open that, and then the content will be part of this request. The signing name would be Kubernetes .io/kube -API server -client. So this is the signing, the authority that signs the certificate. And in our environment, this is the default signing request authority. And then under users, we need to specify the client auth, because this is a client certificate. There are different certificates of, for instance, there is the type of certificate that is generated for encryption. That will be a different type. So we need to specify client auths. That would be, but that request will be sent to the API server. And then you have 1 hour to approve it. So once the request is sent to API, you have 1 hour to approve it. Remember, if you don't approve it after 1 hour, it will be garbage collected by the API server. So you need to go through the process again. And then once you approve that, then we need to get the certificate, which is embedded in the CSR, and is also encoded in base64. So we need to decode that. So this is the command, kubectl get certificate signing request, and then this is the name of the signing request that we made earlier, and then we get the content as JSON, and within that we grab the certificate, and then we basically decode that, and that would generate a client certificate for John. So now we have the client certificate generated. We also have the private key. And the next step would be for admins to generate a config file based on these two information and the CA certificate. We'll go through that process of generating into configuration a little bit later, but this is basically an overview of how we need to generate a certificate and a private key. So once we generate a client certificate for our user, we also need to generate the config file. We'll go through the mechanics of how we do it during the demos, but over here, I just want to go through the layout so you understand what are the parts that are involved in this config file. So let's go through that. The first section is clusters, and then dash clusters. So you can have multiple clusters. You define multiple clusters here. So, and the cluster we need to specify. And these are generated by command line. You don't have to actually code this. We'll go through that again during the demo. But once, as part of that, we generate once generated the cluster section, then we can have multiple clusters that a client can connect to. So each one is specified by dash cluster, and then under that, specify the certificate authority data, and this is basically the CA certificate for that cluster that you're connecting to. And then this is the server address, which is basically HTTPS, the IP address, and the port by default is 6443. And then we name this cluster, we call it whatever we want. I call that cluster 1. So again, we can have multiple clusters under this. Next section is context. So context, you can think of it as like a connection string that you connect, you can connect to a database. So you have cluster, that would be the name of cluster that we specify here, cluster 1. So that will, let's say that's our database name, kind of like. And then the user, what's the name of the user that will be connecting to that. And we call that John Doe, and we'll define John Doe in the user section below that. But for now, so John Doe, and this is the cluster that we'll be connecting to. So and we name this context, I called it John Doe at Kubernetes, so you can call it whatever you want. So that's basically the name of this context. And then we specify the current context equal to whatever. So again, remember, we can have multiple, we can connect to multiple clusters, and then each will have its own context and clusters and users. So if you don't specify anything, by default, it's going to use a context called John Doe at Kubernetes, which is this guy here. Again, you can have multiple contexts below that. And then the next section would be users, and then dash name. So this is the name you specified up here. I mean, that would refer to this section here, which has the user section, and under that, client certificate data. And this would be actually the user certificate that we generated in the previous section. That would be, actually the whole thing would be copied here. And then the client data, and the client data, we have the user key. So if you recall, we generated a certificate and a key for John Doe, and those would be copied over here. So next we're going to do a demo. We're just going to create a new client certificate, and we go through the process as we described earlier. We are in Visual Studio Code now to request a certificate for our new employee named John Doe. And the first thing that we need to do is to generate a private key. So again, the command is openSSL gen RSA-out. I name it john.doe.key, and then the strength of the key, which is 2048 bit. So let's go ahead and generate that. And then on line 6, we need to create a CSR, or certificate requesting, a certificate signing request. And this is the command that we went over during the presentation. OpenSSL REQ, or request, minus new dash key, and then the name of the file that contains the private key we've generated in the previous step, which was john.doe.key. And then we want to put that inside another file, and we call it johndoe.csr. The result will be in there. And then we need to specify the subject, that is the name of that appear on the certificate, and that would be CN equal to John Doe. And then we'll specify the roles that we want to specify our new user will be belonging to. And again, John will be belonging to the marketing, and HR developer role. So let's go ahead and run that. That's done. Now we can peek inside the file that was generated, the signing request file. Let's go ahead and run that, and we see that that's the content of that. So we need to now read again the content of that file, and we need to encode it in base 64. We need to remove the head and the headings and the trailers and copy it into a different files. And this is the command cat and the name of the CSR file, and then we pump it into base 64. We encode it in code 64. We remove the headers and the trailers, and then we dump it into that file. So let's go ahead and do that. That's done. Now we can peek inside the file we just created. We basically encoded version of the file that we just saw earlier. Now on line 20, we need to send the request, the CSR that we just generated. We need to send it to Kubernetes API server to approve or to make a request, formal request. And again, we went through the command. We're doing doc now, and then the command would be again apply kubectl apply, and then we generate the rest of it on the fly. So API version again, certificates.k8s.io/v1. The kind is certificate signing request. And then the name, again, we select a name for it. I call it John Doe. Again, this is the request name. It's not the name of the certificate. And we specify groups. It's system.authenticated. This is a built-in group that all authenticated members of the cluster will be belonging to. And then inside request, we will open, basically as part of this, we extract the content of the file we generated up here, which was johndoe.base64.csr. And that would be part of this request that is sent to API server. And then signature name again, signer name, sorry, it would be this one. And then the usage, we specify a client auth as we described earlier. So let's go ahead and run that. So the request has been sent to the API server. Now we can verify our request. So kubectl get certificate signing request. Let's go ahead and run that, and we will see that there is one called John Doe we just created. And then we'll see under condition is pending. So again, remember, you have 1 hour to approve it. Otherwise, it will be garbage collected by the API server. And then on line 40, we are going to approve that. So kubectl certificate approve John Doe. Let's go ahead and run that. And then we can do another status, and kubectl get certificate signing request. And the name, now we have John Doe. Let's go ahead and run that. And we'll see that it says the condition changed to approved and issued. So we can now go ahead and get the certificate will be inside the CSR request. So let's go ahead, we need to go inside that. And as mentioned again earlier in the presentation section, we can get that from inside. We can get the certificate. We can go ahead and print it out. And by going inside certificate signing request, this is the name of the request, and then -o JSON path. So we'll go inside and grab the certificate from inside that, and then we decode that because that's encoded in base 64. We decode that, and this is what it looks like. So this is a certificate. Now we can do the same thing again, but this time we're going to now dump it into a file called johndoe.cert. So let's go ahead and run that. So now we have the certificate created for John. We can Again, peek inside the certificate, line 58. Go ahead, and this is the basic certificate. Now we can view that in a human readable form. OpenSSL X509-in, so that would be the certificate we just created or extracted from a certificate signing request. Dash text, no out, dash, and then pump it into head. We're going to see the first 15 lines of code. So basically, we're going to show that in the more human readable format. And this is what we get. So important things here to note that the CN is Kubernetes, so because we are using the self-signed certificate or PKI that was generated or was set up as part of the setting up Kubernetes. And then we'll have here subject equal to, and then we have, it first shows the organization, O is equal to HR dev, and O equal to marketing. So these are the two groups that we assign John to, or roles that we assign to, and CN, that's John's name. And then this is the public key. It's got 2048-bit strong. So this is how you generate the certificate for your user. So the next step for us is to also generate a configuration, the authentication configuration file we just described a little bit earlier. Now that we have a client certificate for our client, John Doe, we also generated a private key that goes with it. In this section, we're going to create a configuration, authentication configuration file for John so that he can connect to our Kubernetes cluster. Before that, I want to introduce you to kubectl config. So this is the command that we'll be using quite frequently here to create and manipulate the configuration file. So kubectl config, and then when we say view on line 5, it will show us the configuration that my configuration on my machine, which is under in my home directory under .kube folder. So let's go ahead and run that. So basically, you're looking at the configuration in my machine. So let's clear that. And then one thing I forgot to mention is that when we look at the user, we'll see that the certificate and also the key, they are redacted. Basically, it doesn't show up for brevity. If you want to show those information, we can add the .raw switch to it. Let's go ahead and run that, and this time we'll see that it will also show us the key and certificate. So if you want to see everything, use the --raw. Now I think we are ready now to start working on creating an authentication configuration file for our user. So the first thing that we need to do is set the cluster section. So on line 11, kubectl config, set cluster, and we name it whatever we want. I call it cluster 1. We also need to specify the API server, so -- server equal to HTTPS, and the IP address of our master, which I added up here. And if you're following this, make sure that you change it to the IP address of your master in your cluster. And then below that, -- certificate authority. Now we need to grab the CA cert, which is on each node under /etc/Kubernetes/PKI, and then CA.crt. That's what we talked about earlier about the certificate. So we get that certificate from there. And then --embed cert is equal to true. So it's going to embed that certificate inside the configuration file. And finally, we specify a name for configuration, and then --kube-config equal to john.doe.conf. So for now, during this time, I'm going to call that john.doe.conf. But at the end, I'm going to rename it to just conf because that's what is expected. So let's go ahead and run that. So we created that. So we want to make sure that the file was generated. So ls john.do.conf. Let's go to run that. And we'll see that, yeah, indeed, we do have this john.do.conf file. And then on line 22, kubectl config view -- config equal to and the name of our config file. Let's go ahead and run that. And we'll see that right now the only thing that we have right now is the cluster information. And then so we're going to actually step by step build this configuration file to its completion. And then the next section would be the user section. So on line 26, kubectl config set.credentials, and then the name, I call this john.do. So this is basically our the config section for our user, and then -- client equal to -- client.key equal to john.do.key. So this is the private key for John, and then -- client certificate equal to, this is the certificate we generated for John, and then -- embed cert again is equal to true, and again we are adding that to our configuration file, which is john.do.conf. Let's go ahead and run that, and then we can now verify on line 38 kubectl config view -- config file and our file name. And we'll see that now we have, in addition to clusters, we also have the user section, which is john.do. So we have the user section now and the cluster section. Now the next section is we want to set the context on line 37. kubectl config set context and then john.do at cluster 1. So this is again the configuration, the context section of the file. We need to specify the cluster, which is cluster 1 that we created earlier, and then the user that we also created earlier, john.do, and then there's a file. So basically, this will create a section, a context section called john.do at cluster 1, and this all the information about what cluster and what user will be used to connect to the Kubernetes. So let's go ahead and run that. And again, we can run that config or confirm that kubectl config view and then the name of our file again. And we can see that now we have almost everything that we need, except one last thing that we need to do is we need to set the default context to a context. So kubectl config use context. So that will set the context to john.do at cluster 1. So this is the user the context that we created up here. So by default, if John doesn't specify any context, we're going to use that context. So let's go ahead and run that. And then now on line 51, let's see if John can do anything in the cluster. So let's do kubectl get pod -- config file equal to and the name of configuration file. So if I don't specify -- config file, it's going to use my configuration. So we don't want that. So we're going to kind of point it to to John's configuration file. So let's go ahead and run that. And see that it says error from server, forbidden, pod is forbidden, user john.do cannot list resource pod. So we knew that obviously John doesn't really have right now any access to any of the objects in the cluster. He's only right now allowed to authenticate against the cluster. In the next section, we'll be talking about RBAC and how we can assign permissions for users or to the objects that are in the cluster, such as pods and other objects, and we'll talk about RBAC later on. But for now, we'll see that John doesn't have it. But at least he can connect to the server. So authentication is proceeding, authorization to do anything is failing. One trick that you can use on line 54, we can impersonate. So the command kubectl auth can I. So can I list pods and then dash the configuration file. So basically you say, can I, you're impersonating. So basically you're impersonating John, and using that impersonation, can you list the pods? If you run that, and the answer is no, as we saw in the above step. So this is a really not nice trick that you can use once you have the configuration file created. And we'll go through that in more detail when we get to the RBAC section and authorization. But I want to bring it up here. Keep in mind that you are able to impersonate a user. If they once you generated the configuration file, you can impersonate, and this is to ensure that the user has enough permission to do their job, and also the user doesn't have more permission that they require. So we go through that in more detail in the RBAC section. And lastly, we're going to rename the john.do.conf into just conf file. So then now we can send this to John. Obviously, we haven't given them any permissions yet, and that's what we're going to do next. We're going to talk about RBAC and how we can assign different permissions to users to use object in the Kubernetes environment. So in the previous demos, we created a client certificate, X509 client certificate for a user named John Doe. We also created a configuration file. So he'll be able to now log into Kubernetes through kubectl, but this really is not authorized to do anything. You haven't given him any rights yet. And authorization for users, people, and service account are done through role-based access control, or RBAC. We've covered RBAC previously. If you want to watch that, I provide a link over here. So although X509 client certificate authentication is a good method for small to medium organizations, for larger organizations, this becomes a problem. There's a lot of overhead is associated with creating and managing users. And also, one of the big problems with certificate is, although you can create a role, you can assign a role when you create a certificate for a user, but if a user needs to move to a different role, then you have to recreate a new certificate. So it's not really going to work in a really large organization. So for those types of organization, it's better to delegate managing the users to different systems, like external systems, such as OpenID or LDAP. And in a future video, we will cover OpenID. I hope you enjoyed this video. If you did, then give it a like and also share it with your colleagues and friends. Thank you.